In the late 1980s, computing power was flooding into enterprise offices, but managing it was a totally uncoordinated land grab. IT departments were obsessed with buying and rack-mounting physical servers while virtually ignoring how those machines actually ran day to day. To monitor this sprawling infrastructure, human operators had to sit inside a network operations center, staring at a massive wall of physical screens. It was entirely reactive. You simply watched the monitors and waited for a red light to flash, telling you a hard drive or a router had already died. Because operators were constantly putting out fires, business leaders had zero visibility into the quality of the technology they were paying for. To the executives writing the checks, the IT department looked like a giant black hole for capital expenditure. The sheer potential of the technology had completely outpaced the organizational capacity to manage it. Without a centralized system in place, companies were bleeding money and failing to see any real return on their digital investments. To fix this fragmented chaos, the UK government's Central Computer and Telecommunications Agency stepped in. An executive named Pete Skinner assembled a team to identify and write down the exact practices that highly efficient organizations were already using to keep their systems running smoothly. Originally, they planned to create a rigid method for IT operations. They quickly realized, however, that a strict set of laws would fail in a fast-moving industry. Instead, they packaged their findings as a flexible collection of best practices. They called it the Information Technology Infrastructure Library, or ITIL. ITIL focused the entire operational lifecycle on the delivery of holistic services to the end user. This framework moved the goalposts from hardware maintenance to the end-to-end reliability of the user's experience. By defining standard procedures for how to handle a software update or a server outage, ITIL proved that standardized processes are an absolute requirement for scaling digital operations. You cannot scale a system if the people running it don't speak a common language. As enterprise networks expanded into complex, distributed client-server environments in the 1990s, the demand for management tools exploded. 4 major technology titans, IBM, HP, CA Technologies, and BMC Software rose to dominate the space. But instead of building unified platforms from scratch, these vendors went on a massive shopping spree. They aggressively acquired smaller, specialized software companies and haphazardly stitched those independent tools together into sprawling, monolithic management suites. For the IT teams actually using the software, this created an absolute nightmare. A single implementation could cost over $1 million in licensing and take years to configure. The tools were so convoluted that companies often gave up, leaving expensive software sitting unused as shelfware. By prioritizing high-margin maintenance fees on these bloated, acquired products, the Big Four effectively trapped their enterprise customers. They extracted massive revenue without offering organic innovation or any real operational agility. This diagram shows what happens when a top-level network router fails. Because every device connected to it loses connection, a single failure triggers a cascade of hundreds of false down alerts. Inside the operations center, this was known as an alert storm, and it completely overwhelmed the engineering teams.
A tool called Netcool solved this by introducing event correlation. Acting as a manager for all the other monitors, it ingested all that alert data and instantly suppressed the noise from the downstream devices. By isolating the true root cause, it drastically reduced mean time to repair, the critical metric measuring how fast an outage gets fixed. While tools like Netcool managed the hardware plumbing, a new discipline called application performance management emerged to look inside the software itself. As web-based applications grew more complex, monitoring the physical server was no longer enough. Engineers needed to see the actual code execution layer. This marked the transition to white box monitoring. Instead of treating a server like a closed black box and simply asking if it had power, teams could look inside and see exactly why a database query was hanging or a web transaction was stalling. For the first time, they were tracking the actual user experience. The tools for finding problems were getting incredibly precise, but the legacy suites used to log and assign those problems were still massive, rigid applications. The engineering side was advancing rapidly, yet the software used to execute the modern ITIL workflows was too clunky to keep up. By the mid-2000s, the internet evolved into a highly interactive, fast-paced environment known as Web 2.0. This new era required a level of agility that the heavy, static, on-premise management tools simply could not provide. Up-and-coming companies spotted the vulnerability. Vendors like SolarWinds bypassed the million-dollar corporate sales cycles entirely. They allowed IT administrators to directly download cheap, lightweight monitoring tools straight from the web, spreading through organizations from the bottom up. Then, industry veteran Fred Luddy founded ServiceNow. He stripped away the massive upfront licensing fees and physical installations, offering a pure, cloud-based platform on a software-as-a-service subscription model. This animation shows ServiceNow's advantage. Older tools relied on hard-coded customizations that shattered during updates. ServiceNow used a metadata-driven engine. This flexible layer allowed companies to heavily customize workflows while ensuring the underlying system remained entirely upgrade-safe. This subscription model democratized high-end service management. Mid-market companies could finally access enterprise-grade workflows, freeing them from the crushing technical debt and extortionate maintenance fees of the legacy giants. Caught in their own legacy trap and addicted to those maintenance fees, the monolithic vendors struggled to adapt to the cloud. Over time, their market share declined, and many of their product divisions were sold off, devolving into holding companies acting as software retirement homes. The industry finally had the right combination of theory and technology. By running the universal, standardized language of ITIL on top of flexible, cloud-native platforms, global enterprises could rapidly coordinate their digital operations without breaking the underlying code. The real-world results were massive drops in major system incidents. Organizations could implement service-level agreements, clear, data-driven contracts that held the IT department directly accountable for application speed and reliability. Replacing reactive hardware monitoring with proactive service management altered the identity of the entire discipline. In the modern digital age, IT infrastructure functions as the core service of the business.